Hi, welcome to this video presentation. I am A. Subashini, Associate Professor, PG and Research Department of Chemistry, Sita Lakshmi Ramaswamy College, Tiruchirappalli. Let us discuss about term symbols. Atomic term symbols. Introduction. In an atom, an electron may have a spin angular momentum and an orbital angular momentum which may interact or couple to give a resultant angular momentum. The resultant angular momentum and energy of the system is expressed in term symbols. Term symbols apply to both neutral and charged atoms and to their ground and excited states. Russell-Sander coupling, the term symbol for a particular atomic term in the form of 2s plus 1 Lj. Here, S denotes the total spin quantum number. 2s plus 1 gives the multiplicity of the state. L, total orbital angular momentum. Values of L, 0 means S, 1 means P, 2 means D, 3 means F, 4 means G, and 5 means H. J, total angular momentum number. We can have J values L plus S up to L minus S. It is necessary to gain some knowledge on nature of energy levels of the free metal ion. Principal quantum number n values 1, 2, 3 corresponding to the order of the orbit containing electrons. The azimuthal or orbital quantum number L have values 0, 1, 2, 3 up to n minus 1. Describes the shape and orbital angular momentum of electron in an orbital. The magnetic quantum number ML have values plus 1, 0, minus 1. The spin quantum number ms of electron with either plus half spin or minus half values. The ground state term for a free ion with P1 configuration. We know that there are 3 subshells present in p orbital. Distribute the electrons in the available orbitals following the Pauli's exclusion principle. First, we fill the orbitals with highest ML value with 1 electron each and assign a maximal MS to them. Here, in the first level, we have 1 electron. S equal to total spin quantum number. A single electron in the p orbitals gives spin value equal to half. So the spin multiplicity 2s plus 1, 2 into half plus 1. Both the denominator and the numerator we have 2. So it can be cancelled out. 1 plus 1 equal to 2. So the spin multiplicity equal to 2 doublet. 1 electron. So 1 means the term P. L equal to orbital quantum number. L1 means P. We know the multiplicity as well as the term. Next we can calculate J values. J equal to total angular momentum quantum number. It can have values L plus S up to L minus S. So L1 plus 1 electron half spin 1 plus S 1 minus half. 1 plus half 1 and a half or 3 by 2. 1 minus half half. The J value is taken as half because when the subshell is less than half filled, the minimum J value is selected. Therefore, J equal to L minus S half. The ground state term for a free ion with the P1 configuration is 2p half. The ground state term for a free ion with P2 configuration. There are 3 subshells present in p orbital. 2 electrons in the p orbitals with the parallel spins gives half plus half equal to 1. 2s plus 1 which is equal to 2 into 1 plus 1 which is equal to 3. So spin multiplicity 3, that is triplet. So L orbital quantum number L equal to 1 means P. J total angular momentum quantum number. J can have values L plus S up to L minus S. Here L value is 1 and spin value 1. 1 plus 1 equal to 2. L value 1 minus S value 1. 1 minus 1 equal to 0. The J value taken as 0 because when less than half of the subshell is occupied, the minimum J value is selected. Therefore, J which is equal to L minus S 0. The ground state term for a free ion with P2 configuration is 3P0. The ground state term for a free ion with P3 configuration, there are 3 subshells present in p orbital, 3 electrons in the p orbital, that is half-filled configuration, S which is equal to 3 by 2, 2 into S plus 1 which is equal to 2 into 3 by 2 plus 1. Both the denominator and the numerator we have 2, it can be cancelled out. Therefore, spin multiplicity equal to 4, that is quartet. L orbital quantum number, L which is equal to 0, it denotes S term. J total angular momentum quantum number, J which is equal to L plus S up to L minus S. L value is 0 plus total spin 3 by 2 and L value is 0 minus S 3 by 2. So J value which is equal to 3 by 2. Since the subshell is half filled, L equal to 0 and hence J equals S. The ground state term for a free ion with P3 configuration is 4s 3 by 2. The ground state term for a free ion with P4 configuration. 4 electrons in the p orbitals, more than half filled, S value which is equal to half. 2s plus 1 which is equal to 2 into 1 plus 1. Therefore 3. Spin multiplicity is triplet here. L orbital quantum number, L equal to 1. So L equal to P term. J total angular momentum quantum number, J which is equal to L plus S up to L minus S. Therefore, J which is equal to L1 plus S1, 1 plus 1 equal to 2 and L1 minus S1, 1 minus 1 0. We can take the J value as 2 because the subshell is more than half filled. We choose the maximum value for J, J which is equal to L plus S which is equal to 2. The ground state term for a free ion with the P4 configuration is 3P2. The ground state term for a free ion with P5 configuration. There are 3 subshells present in p orbitals, 5 electrons in p orbitals, only 1 electron has spin, S which is equal to half, 2s plus 1 which is equal to 2 into half plus 1 which is equal to 2. Spin multiplicity is 2, that is doublet. L orbital quantum number, L which is equal to 1, it denotes P term. J total angular momentum quantum number, J which is equal to L plus S up to L minus S. L value is 1, S value is half, 1 plus half which is equal to 1 and a half or 3 by 2. L value is 1 minus S value is half, 1 minus half equal to half. We can take the J value as 3 by 2 because when the subshell is more than half filled, we choose the maximum J value. J which is equal to L plus S which is equal to 3 by 2. The ground state term for a free ion with P5 configuration is 2P 3 by 2. The ground state term for a free ion with P6 configuration, there are 3 subshells present in p orbital. Distribute the electrons in the available orbitals following the Pauli's exclusion principle. First, we fill the orbitals with the highest ML value with 1 electron each and assign a maximal MS to them. S, total spin quantum number, fully filled p orbitals with 6 electrons when spins are paired s equal to 0. 2s plus 1 which is equal to 2 into 0 plus 1, 1. Spin multiplicity is 1, that is singlet. L, orbital quantum number, L equal to 0, it denotes S term. J, total angular momentum quantum number, J, L plus S up to L minus S. L value is 0, S value is 0, L plus S equal to 0 and L minus S equal to 0. The J value is taken as 0. The ground state term for a free ion with P6 configuration is 1s0. Understanding term symbol help us to analyze the electronic configurations and energy states of atoms more effectively. The ground state term symbol for p electron configuration is determined using Hund's rule, which prioritizes maximum spin multiplicity and maximum orbital angular momentum. For a single p electron in p1 or p5, the ground state term is 2p half and 2p 3 by 2. If less than half filled, we choose 2p half. If more than half filled, we choose 2p 3 by 2 being the ground state due to lower energy. For p2 and p4, the ground state term is 3p0 or 3p2, while for half-filled p3 configuration, the ground state is 4s 3 by 2. Thank you.